Hello, I'm Andy Christopher and this is Barbara George Jagley from the Department of Primary Industries.
My background is as a cropping researcher and I own a small farm in southeast Queensland.
I grew up on a cropping and sheep property in South Australia and I've worked as a researcher in broadacre cropping for over 30 years.
We are both part of DPI's Carbon Outreach team, which is tasked with bringing independent advice to Queensland producers about emissions reporting and reducing greenhouse gas emissions.
So Barb, how do you reduce emissions through management or sequestration in soil or vegetation on a broadacre farm?
In broadacre cropping, nitrous oxide is by far the largest contributor to greenhouse gas emissions, and it is 265 times more potent in warming the atmosphere than carbon dioxide. There are two main processes in the nitrogen cycle that give off nitrous oxide into the atmosphere. Nitrification occurs mainly in warm aerobic soils. Losses through nitrification are usually small, but they can occur over an extended period. Denitrification occurs when mineral N is high, which is usually straight after applying fertilizers. Losses are greatest in warm, wet soils with low oxygen availability. Inefficient nitrogen use can result in excess nitrate N in the soil profile, which can lead to increased nitrous oxide emissions as well. Applying the 4 R's of optimal nitrogen fertilizer is a good strategy to reduce nitrous oxide emissions from broadacre cropping. Adhering to this will also save you dollars and increase your profitability. To remind you, this is what the 4 R's stand for. Right source, nitrogen in the form of ammonium or in products where the rate of conversion from ammonium to nitrate is slowed, usually emits less nitrous oxide. Right time, supply nitrogen fertilizer at key plant development stages during high demand periods to increase plant uptake. Avoid tillage under wet conditions and applying nitrogen fertilizer following irrigation or to warm, waterlogged soils, as this would increase losses through leaching and volatilization. Delay application in situations where soil saturation is likely to occur. Right rate. Undertake soil and plant testing to determine the available nitrogen supply, including manure, compost, and crop residues already in the system. Assess plant and soil nutrient demand and base application rate on a target yield. Do not exceed recommended application rates and adjust for rainfall and temperatures. Right place. Fertilizer applied to dry topsoil is inaccessible. Undertake some soil mapping and testing to understand the different soil types and nutrient levels across your property.
Other management options to reduce release of nitrous oxide are reduce leaching and runoff, reduce waterlogging through good drainage and irrigation management, avoid compaction through minimum till or controlled traffic, avoid soil disturbance which can stimulate microbial denitrification, improve soil and plant health, and address soil constraints rather than just applying more fertiliser. Avoid erosion, avoid lengthy fallows, and consider including legumes in your rotation. Other options for reducing your carbon footprint in broadacre cropping are reduced use of electricity and fuel, using low CO2 energy sources from both on and off the farm, reduce use of pesticides through precision farming, and acting to increase your soil carbon.
Apart from sequestering carbon dioxide from the atmosphere, increasing your soil carbon has many benefits and increases your profitability. It has been suggested that every 1% of soil organic carbon that is added to the top 10 centimeters of soil is equivalent to $1,500 to $2,000 worth of fertilizer.
Do you want to know more about this topic and what it means for you? We've produced several more of these videos addressing different aspects of what broadacre farmers need to know about greenhouse gases and emissions accounting. The Carbon Outreach Project is funded through the Farm Business Resilience Program, which is jointly funded by the Australian and Queensland governments. We'd also like to acknowledge the University of Melbourne that produced many of the education materials we drew on for this presentation.